Hello everyone, I welcome you in this lecture, and in this lecture we will study to express any value of function in terms of leading terms and leading coefficients. So that we will understand, like we have to find value of, say, a is the initial point, like we are given the values a plus h, a plus 2h. A is the initial term or leading term. Its value is here y of a plus h, y of a plus 2h, something like that. And after that you will form the first order difference table delta y, and the value in between them you will write, that will be delta y naught, something like that. So if you have to find the value of yn, if this value is denoted by y naught, you have to find the value of yn, then that will be ya plus nh, and you know this will be equal to operating the shift operator upon ya n times. Like we apply a shift operator upon y one time, so what will shift operator do? If I write it, it is equal to y naught is, say, equal to f of a. Fine. So this shift operator will shift it with a plus h, you know the property, and this a plus h is nothing but a plus h, and this value is termed as y1. So if once we apply the shift operator upon this one, then it goes to y1. If we apply it 2 times, then this will go to y2, and if I will apply n times, then it will go to yn. So if I say, if I apply it upon ya, and ya term is denoted as y naught, so then this will go to yn. This is a shifting by a shifting operator n times. Okay, so this will give, and we know that the relation between forward difference and shifting operator is this one. You have derived it in the earlier lecture. So now I am going to put it over here. So this will be 1 plus delta n y naught. Fine. So here you can expand it with the help of the binomial theorem. So that will give the required result. Like we expand it, 1 plus nc1 delta plus nc2 delta square plus nc3 delta cube up to, that will be delta n. This will be y naught, and these terms are the leading terms. This is leading coefficient, this one, and this is the leading coefficient of difference table of first column, first order difference table, difference column. So this will be y naught, this will be n delta y naught n minus 1 by 2 factorial delta square y naught, and so on. You will keep continuing going like that. In the end we have delta n y naught. So ultimately we have expressed any value yn in terms of the leading term and leading coefficients. Okay, so that is the article that we have to study. Now we will take up one problem based upon this article, and the problem statement of the problem is something like this is the problem. If the third differences are constant, then find y6 when y0 is equal to -3, y1 is equal to 6, y2 is equal to 8, and y3 is equal to 12. So we have to find y6. So this will be done with the help of same, because we have to extrapolate. At 0 it is -3, at value at 1 it is 6, 2, 4, 8 and 3 it is 12. We have to find that y6. So we know that y6, if we apply the shift operator 6 times upon y0, we will get y6. So you can see over here also, y0 when one shift operator is applied will go to y1, when another one y2, another one y3, another one y4, one more y5, and one more y6. So we have to determine y6. So how many shift operator we have applied? Let's count. 1, 2, 3, 4, 5, and here is also 1. It is 6. So 6 times if we apply upon y0, we will get y6. And we also know that shift operator is equal to 1 plus delta raised to the power 6 y0. Now this will be opened and you will get C 60 plus C 61 delta plus C 62 delta square plus 6 C3 delta cube 6 C4 delta 4 plus 6 C5 delta 5 plus C6 delta 6, and outside is using the binomial theorem, and outside is y0. Outside is y0. So we know these values. This is 1, 6, 6 to 15. It will be 20. It will be likewise 15. It will be 6, and it will be delta 6, and outside is y0. Now this will go inside. So we need these values, and it can easily be then solved. Fine. So now we'll try to find these values by forming the table. So this is the formula expressing y6 in terms of leading term and leading coefficients. Fine. So now let me make the table, and the table is given by, here you see how we'll form the table. I have written y -3, 6, 8, 12. Now you will leave one space blank, this space blank. Now in between them you will write over here 6. It will then this quantity which will be written over here will be 6 minus 3 is nothing but 9. So this will be 9. 8 minus 6 nothing but 2. 12 minus 8 4. Next will be delta square y. Between this and this 2 minus 9 is minus 7. 4 minus 2 is 2. Now see, next will be delta cube y0. 2 minus 7 again minus 7 is 2 plus 7, which is 9. Fine. So this is 9. So we don't require the fourth one. So if third differences are constant, so this difference has come as a constant, so we have to determine y6. So here this is the value of, if I say this is the value of y0, this is the value of delta y0, and this is the value of first value in this column, delta square y0, and this is the value of delta cube y0. So in this we have only up to here, so these terms will be ineffective, and so we are going to write this formula as is equal to y0 plus 6 delta y0 plus 15 delta square y0 plus 20 delta cube y0. Since we don't have other terms which are, so we don't have higher terms than delta cube y0, so you may neglect them. So now substituting the values, what is y0? It will be minus 3, 6. What is delta y0? It is 9. And what is delta square y0? Minus 7 plus 20, it's 9. So this will be minus 3, it will be 54, and it will be minus 105 plus 180. So this thing will be 234. These two both will add up, and these two minus term will be together. When it will go, it will give 126. So this implies that y6 is equal to 126, and this y6 we have determined with the help of the leading coefficient and leading term and leading coefficients. So that y6 we have determined by expressing y6 in terms of leading term and leading coefficient. So this article is important from examination point of view. So that's all I have from this lecture, and if you like the lecture, please like, subscribe, share and comment. This is Dr. Rajesh saying goodbye, take care, bye bye, and see you soon.